Hi guys, and welcome to the first tutorial on PyTorch. In this tutorial I am going to show you some basic operations using PyTorch and a bit comparison using NumPy and PyTorch, so that you can see that how much NumPy and PyTorch are so much similar in a way. Okay, um, so that we can move forward to the next tutorials where I am going to show you different mechanisms for that. I mean, implementing linear regression, logistic regression, all those things I will show you in the next tutorial. But this tutorial is all about the basics of PyTorch. Okay, so without wasting time, let's start it. The first thing here is, okay, I'm importing. Okay, PyTorch and Umpire imported. So as you can see, I have created an array. Okay, now this array contains a 2D. It's a 2D array. Now I'm going to just convert it into a NumPy array. Okay. So this looks like that, and to convert it into a tensor, PyTorch tensor, we are just going to use this, and torch.tensor will convert an array into a tensor type object, where numpy.array converts into a numpy.array. Similarly to numpy are zeros, as you know, numpy.0, if give dimension, it will create a if it is 2, 2, it will create a 2-dimensional array with 4 zeros, right? Like this. Tensor.zeros does the same thing. Numpy.ones, okay, it's not numpy, it's np.ones create a 3-dimensional array of each containing 3 elements of 1 touch 1. So as you can see that zeros and 1 function are completely same for NumPy and torch. Similarly, when you are creating random number, is np.random.rand, right, for creating random numbers of 2-dimensional random numbers of each containing 2 elements. Similarly, torch will create. Okay, these two are not the same. They do not have the same value. Obviously, they are both different kind of random numbers. It's not random, it's pseudo random. Anyways, that's not a point. So NumPy to torch. Okay, so here we are creating a NumPy array, and let me show you what we have created in the array. Okay, so this is a NumPy array of containing 9 elements, and now we are converting this into a tensor object. So torch.from NumPy will convert a NumPy array into a tensor a torch object or a tensor object. See, this is the thing. Simple, very simple. Okay, and to convert a torch variable to NumPy, same. So we are creating an random torch object, torch.su, this is object, and now to convert in NumPy, dot NumPy. So dot NumPy will convert, yeah. Okay, now about resizing and reshaping the values. Okay, so we have this torch.ones, right? So we have let's see, this is a torch variable containing 3-dimensional array with 4 elements each. Now what we used to do in NumPy was np dot that NumPy array. So if it is array dot shape, right? So instead of using in array dot shape, we are going to use a dot size. That size function is equivalent to shape function. So let me give it here. Shape in NumPy is equivalent to size. Okay, now view function, the reshape function in NumPy is used with view. Okay, view function. So when you are going to give a dot view, it will convert this 3 dimensional array into a 4-dimensional array containing 3 elements each. See, again if you are using view.12, that means it will convert the whole thing into a 1-dimensional array containing 12 elements in total. So basically it's the reshape function. 2, 6 will convert it into 2-dimensional array each containing 6 elements. Done. Okay, and now for different addition and subtraction and different mathematical operations. So first thing, let's create another array called B. Now let's check the elements of B. Okay, dear, sorry. So B, so we have this 3-dimensional, 4-dimensional 3:4 dimensional array of A and B. We are going to add them. A plus B will add them. Okay, A add B will also add them. Okay, similarly A minus B will subtract them. A dot subtract will subtract A into and A divided by B. Okay, same wise subtract, and if you want to multiply it, it will be same A dot mul, and B will give you same result. Similarly, if you use A dot div, B give you the same results. Now something new that has been introduced in Torch is in place operator. Okay, what is the in place operator? Say you have A, right? So A plus A was giving you 2 into 2, this matrix, right, which is the addition of A and B. Now say if we want to, what would we do if we write A equal to A plus B? Okay, so that is one thing we can do, and another thing we can do is this in place operator. Okay, what in place does is, I will show you. So if you write A dot add B, okay, it gives, now write A. See, the value of A changes. Before, okay, yeah, so that is how it works. If, and it's same for everyone. It has a subtraction function, it's a multiply function, it's a division function also. A dot div, okay, sorry, div B, same thing. What will happen is, this is equivalent to A equal to A plus B or A minus B. So that is the thing. The only difference becomes is, when you are writing a normal addition, it will be A dot add B, and in place operator, what you are going to do is A dot add is A underscore and then B. Okay, that's normal addition, and that will be in place addition. Okay, so now time for mean, median, mode. So we have again we create just a tensor A. Let's see the value. It is from range 1 to 10. Okay, and A dot mean means the mean of all the values in a single dimension. The dimension is 0. Now we create another tensor B, and you can see B, it has this one. Now B dot mean will give you 5.50 for adding this 5, and when you give dimension equal to 1, it will give you the mean of 2. Like when you are giving normal mean, it will add all the elements, right? 1 2 3 4 5 plus 6 7 8 9 10 divided by 10. And when you are giving dimension 1, it will find the mean of this one separately, this one separately, and it will give you the output. Similarly, there is dot median. Okay, so That's basic operations you can do with TensorFlow, sorry, PyTorch, I'm sorry, PyTorch, and how similar it is to NumPy. Thank you guys for watching, and I hope you watched the video, enjoyed the video, and next meet you in the next tutorial. Bye bye.